On to the speaker. Thank you so much.
Hi, everyone. Thank you for attending my talk. My name is Suresh Srinivas. Today, I'll be talking about composability in data, the challenges and the opportunities. Brief background about me. I was one of the core team members that developed Hadoop at Yahoo. Then I went on to be a co-founder at Hortonworks, commercializing the Hadoop project that we had built. After that, I was chief architect of data at Uber. Right now, I'm focusing on building a new project called OpenMetadata. Please check it out. Now, in today's talk, before getting into the composability in data, let's just step back and look at where data is today. Every industry has had, has changed because of digital transformation, and digital transformation has brought explosion of data. And there are billions of dollars that went into in the past decade in building scalable storage and compute platforms and services, both in on-prem and cloud. um, because the volume of data has increased hugely, and a central small team responsible for data no longer can scale. Further, every part of the organization now wants to be data driven, and so you hear data democratization. There are more developers working on data. There are different more kinds of personas that have come onto data. So if you look at within an organization what is happening, all organizations now want to be data driven, derive value from their data. And so because of that, there's a lot of investment that has gone into buying platforms and tools related to data. Also, there are a lot of more data developers that organizations have hired, right? Now with this picture, if you still look at it, um, in the past decade, because all of this has happened so quickly and chaotically, just the data architectures are just organically evolved. Also, data, unlike software engineering practices, software development methodologies, data lacks processes and organization. And of course, missing development methodologies, and that is where I think composability is one of the things that can help data to get to a cleaner and better architecture. Um, so now let's look at composability of data. Um, when I look at literature around this, most of the literature only focuses on composability of data infrastructure, right? So, and many of the blogs and talks that I see are fairly vague. They're still developing the ideas around composability of data infrastructure. What I say is, data infrastructure is composable today, but there are many challenges associated with the current data infrastructure, and we'll talk about that. The missing part of discussion is composability of data. So this is not talked about much. A lot of work is needed in this area, and in this talk, I'll propose some of the ideas on how we can make data composable. So let's look at our data infrastructure today. Um, you have applications that are supported by a number of microservices at the backend. Microservices provide APIs, gateways for receiving events. So essentially, applications are making API calls. All these microservices are working together to provide the functionality that a user needs. All of these microservices are storing their data in transactional databases, often called as online databases as well, sort of like Postgres, MySQL, Oracle. And so these transactional databases are persisting the application state and any other information that is required. Uh, there is an ingestion framework. Typically, these are Airbytes and Fivetran, tools like that. that can actually capture the changes that are happening in the transactional databases, and they ingest this data into either a data lake or a data warehouse. And so that is how, from online data, the events and the transactions are ingested into data lake and data warehouse. And these are transformed using ETL tools to more curated form of data. And these ETL jobs are running on pipelines. Once this curated data is available, it is made available to all the data consumers so that they can consume this data in their favorite tools, and then further transform it to other shapes and forms to help answer their questions quickly and easily. So this data that is available in data warehouse and data lakes are then converted into end user data artifacts like reports, dashboards, machine learning models and machine learning features, metrics for measuring the business KPIs, experimentation for improving the product experience and understanding the impact of changes to the product experience. Many data applications are now being developed by data developers consuming this curated data. And then further, right, there are a lot of other tools that are there for helping discover your data. There are data catalogs. Data quality is important, and hence there are data quality tools, data observability tools. So if you look at this picture, composability is not a choice in data, right? It is the only option because there are different kinds of functions. Some that are related to storage, some that are related to computing, and then some that are related to running periodic jobs and orchestrating jobs. So there are different specialized functionalities. Already the data infrastructure is broken into these different functionalities. So composability is something that is not an option, right, in this kind of a setup. But let's look at what composability, this kind of composability, what kind of challenges it brings, especially for data, right? So the first one is the microservices architecture works, for applications, right, where you have decomposed your backend monolithic, service that you probably started with into smaller microservices, and each microservice is independently owned by different teams, moving at different speeds. So it's been helpful in building, the backend for an application. However, what ends up happening is a single user activity on an application might result in multiple microservices being involved in servicing it, right? And essentially, a single activity is now broken into across many different services. This results in many transactional updates, right? Smaller transactional updates across different databases. Many different events are generated by different microservices. So essentially, you've taken a picture of reality and you've split it into 100 different pieces, right? And while that works in the microservices world, all this data needs to be brought into the offline world. And in order to make sense of what happened, you have to actually stitch together all these different pieces of data, right? And that is non-trivial, right? So it is one of the hardest problems. You've gotten, one activity turned into, tens of events and tens of your transactional data updates. You need to now bring all of them together to build your offline analytics, and that's a big challenge. And in order to address that challenge, right? So microservices not only need to think of how to build an application, right? By working together, they also need to be designed with offline data in mind. So few thoughts here. One is microservices need to be right size, right? So you cannot have, the smaller and smaller the microservices, the more fragmented your data becomes, right, on the offline side. So some thought is needed in right sizing these microservices. And then when you are designing these microservices and producing events and data, there must be a way of, stitching this, the different events and, data transactions together through some kind of a common key that is associated with an activity or some granular granular event that is occurring in an application. Uh, the other thing that also, especially from Uber that we learned is having a lot of microservices that are talking to each other makes your dependency really hard. So grouping microservices together under a domain and then having some kind of a domain gateway to hide the complexity and the implementation details of what microservices are under a gateway might be a good way of doing microservices, and it is also good for the data. So let's look at the next set, next set of problems in the current composability. A lot of organization, develop microservices independently, in silos, right? Teams are just, are exposing APIs, and are there implementation details and schemas and things like that are not exposed to other people who are consuming the APIs on the microservices. Because of this, APIs essentially have schemas of entities and they have types. These schemas and types end up being developed in silos as well. And so an example of this is when I was working at Uber. People would say data is hard to consume, right? At Uber, data is really hard to consume. And when I looked at it, Uber had fairly heavily leaned on microservices as an architectural choice. We had 3,000 microservices. And when I looked at different APIs and the schemas and the data that they're storing in the databases as JSON document, some core types and abstractions like location, point, currency exchange, email address, phone numbers, they all had every microservices ended up defining their own structures and their own types, because of which we had hundreds of locations defined, hundreds of points defined. Sometimes people called something a location when they meant it is a point. Sometimes points were called as location. There are locations that have 3 fields. There are locations that have 8 fields. Imagine getting all this data from all these microservices into the offline world and trying to make sense of all these types, right? Where, they're inconsistent, they're duplicated, they're very confusing because, something is called something else. This was a huge challenge on the offline world, right? Of course, this is also problematic on the API side, but more so on the data side. And so one of the things that we ended up doing is we standardized 80 to 90 types that are commonly used across different microservices and define them as types. This is a way where, for the data of Uber, we started building vocabulary, right? A controlled vocabulary, so that this now ends up becoming the language of data for across APIs and in the offline world. Okay, so this defining types and defining schemas, with a schema first approach is very important for composability of data. So instead of defining every type in every different service in inconsistent manner, define types and evolve them in a standardized manner, and then adopt them across microservices to avoid a lot of confusion, make data easy to use. The other problem in the current composability of data is microservices focus on providing backward compatible APIs. And they can make all kinds of changes in how they are storing the data. That becomes an implementation detail. But as long as APIs are backward compatible, this microservice can be used. However, very less thought goes into keeping events and data that microservices are writing to transactional databases compatible. The reason is microservice, the developers working on microservices think events and data are internal details, but it is no longer so, right? So if you are taking all these events from the microservices and data from the microservices, and you are dependent on your data analytics, right, based on this data that you have collected through ingestion, even events and data needs to be treated as public interfaces, right? Especially the problem with data, right? So, you can change the data online, your database schema constantly without changing the APIs. However, changing the schema of the online database affects the offline side. So there are a couple of choices that are available here. One is, treat events and data also as your public interfaces, and don't expose your online database schema as is. Maybe transform it and then expose it for consumability with backward compatibility. Okay, and then there needs to be backward compatibility checks, right, and processes to keep this data that you're generating, the events and the online transactional data, backward compatible, right? So that is the other challenge. Now with composability, there are a lot of tools that are being used in data for solving many different problems, and some of these tools are solving very narrow problems. So we have been throwing tools at the problems in data. So there is data discovery is a problem. You end up using a data catalog, the quality issues. Then there are this testing, data testing and quality tools that are available. And then there are observability tools, there are data management, compliance tools. So we've been throwing many narrow tools at the problem. And the problem is these tools don't talk to each other. Now, when these tools don't, and then the second problem is because we have different platforms and services, data is stored in many different silos, right? So when these tools don't talk to each other, a lot of knowledge about data, the metadata, is stuck in these different tools, right? So catalog knows where the data is, quality knows what the quality is, observability probably knows what the freshness of data is. But for a user, in order to put the big picture of how the data is doing, he has to jump from tool to tool to tool, right? The other problem is many of these tools also have duplicate metadata of what are the tables, what is the schema, things like that. And so the metadata itself becomes fragmented, duplicated, and then because it is stored across different tools, they are inconsistent, right? So few thoughts here. Tools need to be right sized, right? So there are a lot of narrow tools in data, and some of these tools don't even need to be a standalone tools. They can just be workflows. So there is a thinking that rethink that needs to happen around how the composability of the especially the tool set should look like. And then the second thing is, when these tools exist, they need to be able to talk to each other. They need to be able to reuse the metadata that the other tool is creating. And in order to do that, there is a need for a centralized metadata repository. I'll talk about what we are doing here with OpenMetadata at the later point in the presentation. Now, even with all these tools, there are different people, right? There is people disconnect. There are different personas. There are data scientists, data engineers, data developers. There are legal, compliance, governance folks. All these people are sitting on different kinds of tools. Developers are sitting on developer, tool chain like Git, Docs, Jira, things like that. And then, maybe data scientists are sitting on notebooks and spreadsheets and things like that. So this, different tools, even though data has a lot of tools, and there are, still tools like, these that are not built for data that are being used by different personas. This, further causes fragmentation of data and then siloing of, metadata. So just, switching gear. So now we've looked at what composability looks like in data. What are the challenges? How do we solve some of these challenges? And OpenMetadata is an open source project that we are working on. It's one of the fastest growing projects, and we believe that OpenMetadata, which is a centralized metadata repository, can help solve many of the data composability problems. And as a part of OpenMetadata open source project, our goal is to build an open standard for metadata so that different tools, platforms, modules can freely exchange metadata, right, of a data stack, right, within a data stack. So couple of things. Why metadata is important? Everybody agrees that data is an asset. But we believe metadata is key to unlocking the full potential of that asset, right, to create value. Metadata provides rich context, right, of where the data is, what the data looks like, what is the schema, who is the owner, what is the quality. All of that rich context today is used for data discovery and partially for governance. Uh, Metadata is today not done really well, and it is not used for many other places where it can provide a lot of value, such as data quality, data observability, people collaboration around data, and then data composability. So let's look at how metadata and open metadata can solve some other problems. So with open metadata, what we are trying to do is, instead of every tool having to integrate with every other platform and service out there, we want to build all these integrations in a single place, in a modular way, right? Through concept of connectors for different kinds of data sources, and once this integration is available, all the metadata that is available in your platforms and services are collected and centralized and stored as a metadata graph in open metadata. And then, from the composability perspective, all this metadata is made available as APIs, so that existing tools that have to connect and make a copy of this metadata now can rely on consistent metadata that is available, right? As a metadata graph over APIs. Now, with this, not only they can consume the centralized metadata, they can also produce their own specialized metadata back into the central repository. And this will help a user get as a complete end-to-end picture of what data looks like within an organization, instead of having to jump from tool to tool. Some of the benefits of this is, many of these tools that are, that have very narrow functionality can just be turned into workflows instead of being a standalone tool, right? So let's look at a few advantages of open metadata, especially from the perspective of composability, right? So today, data infrastructure is composable, but nobody knows how it is composed, right? So with this kind of integration and a metadata graph, now you can understand what are the different services that are available for storage, services available for compute, where the data is stored, who the users who own it, who the users are, who are running these compute jobs. All of these things can be connected together with a data graph, metadata graph. And so now you not only have a composable infrastructure, but you also understand how it is composed, which is a very critical knowledge. The second challenge is, today, if you look at, because most of these data tools are self-service, and they encourage brute force approaches to data, right? So you're looking for certain data, you didn't find it, you actually, write a, SQL statement, turn it into a pipeline, and start producing that data. Because because of the self-service, there's a lot of data duplication within an organization. Similar kinds of data sets are being created again and again and again. That can be avoided if we make the data discoverable, easily discoverable, with enough context for people to decide that this is the data I need, I don't need to create it. So that becomes, just solving this data discovery problem, will help in reusability of data, which is, part of, a pillar of composability, right? And so open metadata, because it has all the information about all the data, makes discovery possible, reusability possible, right? The second is, this is just metadata architecture itself, and this applies to data in general. And we talked about microservices as well, where we had reusable types and schema composability. Open metadata uses schema first approach itself, right? So we are practicing what we preach. We use JSON schema for modeling our schemas, and JSON schema has excellent tool support. So here again, what we have is the schemas that are designed, and from these schemas we are generating code for Java, Python, JavaScript database. Data is stored compliant to JSON schema, documentation is generated from it. So here is a place where, once the schema is designed, the design decisions and the choices you have made is reused in generating the code, right, on the other side. So The other part of JSON schema is it makes reusability and modular approach possible. So what we design for metadata is entities, types, and then entities have relationships with each other. Here is an entity as an example defined in JSON schema. The entity has an ID, which makes, you now can import using this ID into any other JSON schema, this entity and the related definitions that are available, right? The types that are available along with the entity. So that's reusability and composability of schema. The second thing that we also, take approach of in open metadata is we have strongly defined types, and these types like ID, email, and things like that are reusable across different entities. Again, right, reusability and then a control vocabulary for metadata data, right? So that's the power of JSON schema. And then, you can actually define all these constraints for min length, max length, regex, min value, max value, things like that. These constraints that you've defined at the schema design time becomes available for the backend for validation automatically, becomes API documentation, all of those things. So JSON schema is a powerful tool, and every engineer should have it in his tool set. Further, right, talking about metadata graph and how composability is exposed in open metadata. Here is a metadata graph of few of the entities that we have in open metadata. And the metadata graph would look like this, right? So there's a database service, maybe an Oracle database service that has a database which has tables, contains tables. Tables are used by metrics. Metrics is a part of dashboard. Dashboard is built by a pipeline, and the pipeline was consuming a Kafka topic. You can build these kind of relationships, as part of metadata graph. You can also further add, this table is owned by this team. The team has these users. All kinds of relationships are built as metadata graph so that you can understand how your data is composed and how your data infra is composed. Finally, right, APIs are also a fundamental pillar of composability, and having rich metadata in a centralized metadata graph is not enough, right? We need to make it shareable, and metadata APIs play a key role in this. In fact, we believe that metadata APIs, just like APIs have transformed many industries, metadata APIs can transform the world of data. Right? And then finally, right, for this metadata to be produced and exchanged and consumed across different services and tools, it has to be vendor neutral, right? It cannot be proprietary format. And it needs to be developed in a community oriented way. And the only way that is possible is through open source. So we have open source project, Open Metadata, which is where different tool vendors and different services are participating, including a lot of users of Open Metadata, in evolving a standard to a controlled vocabulary to describe, capture rich metadata available in the data ecosystem. So just stepping back, we've talked so far about how open metadata builds integration, collects all the metadata from various metadata sources, centralizes them, stores them as a metadata graph. In our open source project, we have also built a discovery and a collaboration application for many of the data personas, right? So that's an application. But from composability perspective, once you have a centralized metadata, many different kinds of both standalone applications and workflows can be built very easily, powered by this metadata, right? So you can build quality tools, you can build cost analysis tools, security audit tools. You can build a data culture tool, which periodically nudges people and makes them do the right thing. Metadata, centralized metadata store becomes foundational building block for composability, where you can now start building different tools and services, and some of these tools can just be workflows. So that's the composability that you get out of open metadata, centralizing metadata store. And so today metadata is just trapped in serving discovery use cases. with this kind of approach, you can enable people collaboration around data, which is a big missing piece, separate from composability. And then you can build a lot of automation, right, in a composable manner. So that is, open metadata, how it is adopting composability and how it is helping, data composability in the data ecosystem. More information is here. Go to open-metadata.org. We have all the information that developers need to participate in the community, become contributors. We also have for users sandbox. You can actually take this sandbox for a spin. So take a look at this project. Check us out if you're interested. Join our project, contribute, become our users. So that is my talk today about composability in data. Thank you for listening. And thank you for Composability Summit for giving me an opportunity to present.
Hey, thank you so much for watching that. I really hope you got value from it. By the way, if you want more where that came from, go to composability.dev and register to be a part of our community today. And if you want to be even more part of our community, go to Twitter and look up JavaScript Jam and follow us. Every Wednesday, we go live at 12 p.m. Pacific Standard Time, and we talk about anything and everything web dev. It's an open mic for everybody, whether you're a beginner, whether you've been doing this forever. We'd love to hear from everybody. And there's always so much value and good conversation going on there. We wanted you to be a part of it too. So come join us. And by the way, if you left a comment below, that's exactly where the comments are going to be answered during the live Q&As with the speakers. JavaScript Jam live on Twitter Spaces. All right, go to JavaScript Jam. Do it now. Follow us. All right. See you soon.